The last piece of factoring that we're going to talk about today deals with special products of trinomials, and these are actually on your formula chart. So we're going to look at what happens when our first and our last term are perfect squares, or if we just have a binomial and both of them are perfect squares. So these are not rules that you need to memorize because they are on the formula chart. You could also always go back to your cross puzzle method and it will work as well. This is just kind of a shortcut for that to happen. So we're going to start with perfect square trinomials where the first and the last term are in fact perfect squares. So when we look inside here, if we were to do our cross puzzle, we will end up with our first term plus our second term times our first term plus our second term. When we take those square roots, right? The square root of anything squared is itself. Anything squared is itself. Now the key is that this middle term is 2 times whatever you get when you take those square roots. The signs, all right, if C is positive, I know they have a B here, but that's just a variable. If C or your last term is positive, that means the signs are the same and you have to look at your middle term. A second way you'll see this written is A plus B, the whole quantity squared, because if you sign something by itself, you will in fact get that squared piece. So I'm going to show you both ways with the shortcut and with the cross puzzle so you can see what's happening here on these examples. So on this first one, I'm going to start with a cross puzzle so you can see, right, A times C, B, the factors of 49, that these are going to be positive, right, because positive times a positive is a positive plus a positive is a positive. So 7 and 7, A is 1, so we can just write x plus 7 times x plus 7, or you can write x plus 7, the whole quantity squared. Now the shortcut for this is this first term is a perfect square. The square root of x squared is just x, and the square root of 49 is 7. Then you have to check this middle term. Is this middle term 2 times the first term times the last term? Well, yeah, this is 14x. That checks. So that means you can do the trick, which just means x plus 7, which we have here, and we have 2 of them, right? So if you look at this one, the square root of x squared is x. The square root of 121 is 11. Check this. Is this 2 times x times 11? Yes, it is. So my factors are x sine of b plus 11. And I can write squared, or I can write x times 11 plus x times 11. And again, if that shortcut is not something that works for you, you can always go back to the cross puzzle. This also works when A is not 1. If I take the square root of this first term, the square root of 4 is 2. The square root of x squared is x. The square root of 9 is 3. So I need to check here. Is this 2 times 2x times 3? Well, 2 times 2 is 4, times 3 is 12. Yes, this is 12x, it works. So then my factors are 2x sine of b plus 3. I can write it squared, or I can say 2x plus 3 times 2x plus 3. And again, you can do that cross puzzle method if you want. Also, this pattern, again, is on your formula chart. It looks like this, right? Oh, my light is blocking, sorry. A squared plus 2ab plus b squared, and then you can see you'll get a plus b quantity squared. So what happens when it's a minus? So let's have a little look at that. So same concept. Notice the only difference in these two patterns is the sign of the middle term. Well, we know that if the middle term is negative and the last term is positive, then our signs are just going to be negative. So it is still the exact same process. So I'm going to say here, again, take the square root here, take the square root here. Make sure that this is in fact 2 times whatever A is times whatever B is. But again, if they're positive, if C is positive and B is negative, then we have A minus B, minus B. Or you can write A minus B, the whole quantity squared. So again, let's have a little look at that over here. So again, I'll show you with the cross puzzle on this first example, right? A times C is positive 81, but B is a negative 18, so that means they're both negative. So 9 times 9 is 81, 9 plus 9 is 18. So I can see here then that my factors are going to be x minus 9 times x minus 9, or I can write x minus 9 quantity squared. If you're going to use this shortcut, you take the square root of the first term. Square root of x squared is x. The square root of 81 is 9. Again, you have to check this middle term because sometimes it's going to look like a perfect squared trinomial, and this middle term is just, maybe it's just a negative 9x, so then it's not going to work. You'll have to use cross puzzle. So we'll say 2 times x times 9, is that 18? Yes, it is. Don't worry about the sign. You're just checking this value piece. So again, if that's the case, 18x, then you can go to here. All right, so here you can say the square root of x squared is x. The square root of 25 is 5. Check the middle. Is this 2 times x times 5? Yes, this is 10x. That works. So again, whatever you got when you took the square root of the first term, sine of b, whatever you got when you took the square root of the last term. Or you can write x minus 5 quantity squared. It also works, again, when a is not 1, because the square root of 9 is 3. Square root of x squared is x. The square root of 64 is 8. So we need to see here, is this 2 times 3x times 8? Well, 2 times 3 is 6. 6 times 8 is 48x. Okay, so that worked. So I can write, right, square root of my first term, sine of b, square root of my last term. Or I can just write the quantity of 3x minus 8 squared. Okay, so again, you can always use the cross puzzle. This is just a shortcut. The last one I have is a difference of 2 squares. Again, this one is on your formula chart as well. Notice you are going to end up with 2 different binomials at this point. There is no middle term here. This is our first term. This is our last term. So really, we could write this a squared minus 0ab minus b squared, right? Our middle term is technically a 0. So when we look at this, we want that middle term to be a 0, so our signs are actually going to be different. One is going to be a positive, and one is going to be a negative. So I'm going to show you that over here with our cross puzzle, and then I'll show you the shortcut. A times C is a negative 36. The only way to get a negative when multiplying is one to be a positive and one to be a negative. We have no middle term here. We have no coefficient of x, so it is 0. Well, how do I get 0? Well, 6 minus 6 is 0. So I can write my factors as x plus 6, x minus 6. And that is my solution. Now, when you go and you do the shortcut, you can say, okay, again, the square root of x squared is x, and the square root of 36 is 6. But you have to remember that when the last term is negative, you have 2 different signs, which is how we got x plus 6 and x minus 6. So if you were to do that here, you would say square root of x squared is x, square root of 100 is 10, and it's a negative 100, so I'm going to have a positive 10 times a negative 10. This trick also works when a is not 1, as long as a is a perfect square. So square root of 25 is 5, the square root of x squared is x, the square root of 16 is 4, and again, c is negative, so I have different signs. I'm going to have one positive and 1 negative. So we're going to practice this today. Please make sure you ask questions if you have them. And again, if you are not comfortable with any of these shortcuts, the cross puzzle works 100% of the time. So feel free to use that if you need to.